Hi, hello, namaskara. Welcome to my channel. So, before studying any topic or any lesson, we must be very perfect in the fundamentals or basic elements of that particular topic. So, my topic is about matrices, and let us discuss the basic elements of the matrices in this video. So, first and foremost thing is definition of matrix. So, let us first discuss about that. So a matrix is a rectangular array of numbers, symbols or expressions arranged in a row and columns. So you can see the representation of the matrix here. So usually we denote matrix by capital letters and we represent it in the square brackets. So A11, A12 up to so on, it will be A1n. So like that, second row A21, A22 and A2n, and this type the columns goes up to n columns and rows goes up to n rows. So the last element will be ann. Here A1 nothing but Aij. I represent rows and J represents columns. So we can see there are several types of matrices. So null matrix, square matrix, diagonal matrix, scalar matrix, unit matrix, upper triangular matrix and lower triangular matrix. So let us study one by one. So first type of matrix is null matrix. Matrix of order m cross n whose all elements are 0. So it may be of any order. So this is nothing but order. M is rows and n is column. So m here, for example, take 3 cross 3 or 2 cross 2. So take 3 cross 3. So every element 3 cross means 3 rows and 3 columns. So 0, 0, 0, 0, 0, 0. So all the elements of matrix are 0. So this represents the null matrix. So second type of matrix is square matrix. A matrix of order m into n such that m equals to n. So here we can see m into n is nothing. It should be always even. Means both should be equal. 3 cross 3, 4 cross 4, 2 cross 2. It should go like this. Means rows and columns should be same. So for example, take 3 cross 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the square matrix. Another example is 2 cross 2. 2 cross 2 like means 2 rows and 2 columns. 0, 8, 9, 7. So next type of matrix is diagonal matrix. In a square matrix, if all the elements except those in leading diagonal are 0, that is Aij equals to 0 for all Ai not equals to j. So for understanding, we'll take one example so you'll understand. So diagonal matrix ಆಗಬೇಕಂದ್ರೆ it should be square matrix. It is mandatory. So take here 3 cross 3. It is square matrix. So they are telling diagonal matrix ಆಗಬೇಕಂದ್ರೆ all the elements except the leading diagonal, means only diagonal elements must be having a non-zero element. ಉಳಿದಿದ್ದೆಲ್ಲ 0 ಆಗಿರಬೇಕು. So this is the diagonal matrix. So next type of matrix is scalar matrix. A square matrix is said to be scalar if ಎರಡು conditions ಇದಾವೆ. Aij equals to 0 for every I not equals to j, and second condition is Aij equals to k for all I equals to j. It is similar to diagonal matrix, but it has some difference in the diagonal elements. ಆ difference ಏನು ಅಂತ ನಾನು ಹೇಳ್ತೀನಿ. So let us take an example like this. So it should also be a square matrix. We'll take 3 cross 3. So Aij equals to k. So I equals to j ಅಂತಂದ್ರೇನು? A11, A22, A33. So ನಾವಿಲ್ಲಿ 3 cross 3 ತಗೊಂಡ್ರಿಂದ this will be the last element. So ಈ ಎಲ್ಲ elements, so we can see here I equals to j ಅಂದರೆ 1 equals to 1 ಇದೆ, 2 equals to 2, 3 equals to 3. So it is nothing but row is equals to column. So ಹಾಗಾಗಿ those elements should be k in the sense any element, but they all should be same. So you can take here 2, 2, 2. So rest all should be 0. So this is scalar matrix. Diagonal elements ಎಲ್ಲವೂ ಸೇಮ್ ಇದ್ರೆ ಅದನ್ನ ನಾವು ಸ್ಕೇಲಾರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ. So next type of matrix is unit matrix. It is very much similar to the scalar matrix. So directly we'll go to the example so we'll understand easily. So we'll take 3 cross 3. It should also be square matrix. So unit matrix is nothing but all the diagonal elements in the matrix should be 1, rest of all them should be 0. It is a unit matrix. So you can see your condition. So if unit ಅಂದರೆ ಯೂನಿಟ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಆಗಬೇಕು ಅಥವಾ ಯೂನಿಟ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಇಸ್ ಆಲ್ಸೋ ಕಾಲ್ಡ್ ಆಸ್ ಐಡೆಂಟಿಟಿ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಸೊ ಅದನ್ನು ನಾವು ಏನಂತ ಕರಿತೀವಿ ಅಂತಂದರೆ, so all the diagonal elements should be 1 here. So next type of matrix is upper triangular matrix. A square matrix A equals to Aij of n cross n is called an upper triangular matrix if Aij equals to 0 for all I is greater than j. So we'll take an example. This is not a standard notation, it is for my convenience I have taken this. So by example we can understand easily. So let's see here. So let us take the matrix of order 3 cross 3. What they have said, Aij equals to 0 for all I greater than j. I means row, j means column. I greater than j ಅಂತಂದ್ರೆ 3, 2, 2, 1, 3, 1, 3, 2, 3, 3. So greater than ivella rows, these are all columns. So we can see every row is greater than that of column. So here we can write 1, 2, 3, 0, 4, 5, 0, 0, 6. See, I greater than 0. This element is A21. I greater than 0. This element is A31. I greater than 0 means I greater than j. So this is also I greater than j. So this is upper triangular matrix. Lower triangular matrix is opposite to the upper triangular matrix. So example 1, 0, 0, 2, 3, 0, 4, 5, 6. So this is lower triangular matrix. So see, triangle is formed lower. Here triangle is formed upper side. So it is called as upper triangular, it is called as lower triangular. In the simple way we can remember this. Okay, these are all types of matrix. So next topic is transpose of a matrix. Let A equals to Aij be a matrix of order m cross n, then n cross m matrix obtained by interchanging the rows and columns of A is called the transpose of matrix A. It is denoted by A dash or A to the power t. So simply we can remember that transpose of a matrix is nothing but interchanging rows into columns. So for example, see, given matrix is A of order 3 cross 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have to find the transpose of this matrix. So transpose of the matrix A is, so rows into columns, interchanging rows into columns is the transpose of that matrix. So first row is transposed to or interchanged to column, that is 1, 2, 3. They are in the first row and they will be interchanged into the first column, like 1, 2, 3. So 4, 5, 6 are in the second row and they are interchanged to second column, 4, 5, 6. In the same way 7, 8, 9, 7, 8, 9 are in the column. So like this, rows are interchanged into columns. It is the transpose of the particular matrix. So the next one is symmetric matrix and skew symmetric matrix. So most of the students will get confused here. So in the simple way we will learn today. So first one is symmetric. A square matrix A equals to Aij is said to be symmetric matrix if A dash equals to A. So this is the condition, that is Aij equals to Aji for all I and j. So by example we understand. So take 2 cross 2 matrix. So 1, 2, 2, 3. This is matrix A. So what is the transpose of this matrix? So as we are already knowing, transpose is obtained by interchanging rows into columns. So this is the first row. So by interchanging it to column, what we will get? 1, 2 in the form of column is again 1, 2. So this one is, so 2 and 3. So we can see here A dash equals to, it is again A, right? So same as the matrix A. So that's why it is a symmetric matrix. So by it is given that Aij equals to Aji, means A11. What is the element of A11? It is 1. So Aj1 is nothing but first column, first row, that is this one only. So A11. So what is A12? First row, second column, first row, second column. What is it? 2. So what is the element of A21? 2, 1. A21 is again 2, right? In the same way we get A21, second row, first column, it is 2. A12 is first row, second column, it is again 2. So every element will satisfy this condition. So this is the symmetric matrix. Simply you remember that A dash ಅಂದರೆ ಯಾವುದೇ ಒಂದು ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಕೊಟ್ಟಾಗ ಅದರ ಟ್ರಾನ್ಸ್ಪೋಸ್ ಮಾಡಿದ್ರು ಕೂಡ ಅದು ಸೇಮ್ ಗಿವನ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಥರನೇ ಬಂದರೆ ಅದು ಸಿಮೆಟ್ರಿಕ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್. ಸೊ ಇನ್ನೊಂದು another type is skew symmetric matrix. Skew symmetric matrix is little different ಅಷ್ಟೇ. ಹೇಗಿದೆ ಅಂತಂದರೆ ಡೈರೆಕ್ಟ್ಲಿ ವಿಲ್ ಗೋ ಟು ದ ಎಕ್ಸಾಂಪಲ್. ಗಿವನ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಏನಿದೆ -2 -3 +3 +2. ಓಕೆ, ಇದು ಟ್ರಾನ್ಸ್ಪೋಸ್ ಏನಾಗುತ್ತೆ? ಟ್ರಾನ್ಸ್ಪೋಸ್ ಏನಾಗುತ್ತೆ? -2 -3 3 ಮತ್ತು 2. ಸೊ ದಿಸ್ ಇಸ್ ದ ಟ್ರಾನ್ಸ್ಪೋಸ್. ಓಕೆ ಓಕೆ, sorry, make a little changes. So take every element as negative elements. So the transpose will be -2 -3 -3 -2. So if we take negative sign outside, what we get? Minus of 2 3 3 2. So right, so this is minus a. So a dash equals to minus a we get. So this is the skew symmetric matrix. So trace of the matrix. Next topic is the sum of diagonal elements of square matrix A is called the trace of A. It is denoted by trace A or TR of A. So that is nothing but, so let us take the example of 3 cross 3. Okay, so what they have said, sum of diagonal elements. I have given here summation of AII. II means same as first row, means row and column should be same of that particular element. A11, A22, A33 up to ANN, like this. So take this 2 7 6 5 10 8 7 9 2. So these are the diagonal elements. So trace is nothing but TR of A. Sum of diagonal elements, right? 2 plus 10 plus 2. What we get? 10 plus 2 is 12. 12 plus 2 is 14. 14 is the trace of this matrix A. Next one is conjugate matrix. Matrix A containing complex numbers as its elements. On replacing its elements by the corresponding conjugate complex number is called conjugate of A, and it is denoted by A bar. You will easily understand this by example. See here. Take 2 cross 2 matrix. Minus I, 2 plus I, 5, 3 minus I. So this is matrix A. So we are already knowing that complex numbers are denoted by A plus IB or X plus IY, anything. Okay, so what they have said, a matrix A containing complex numbers as its elements. So this matrix is containing complex numbers as its elements. So replacing its elements by corresponding conjugate complex number means conjugate of complex number is nothing but C bar. It is X minus IY. This is the conjugate of complex number. So matrix A can be written as positive. So it is negative and it should be positive in the conjugate matrix. 2 minus I, 5 and 3 plus I. This is the conjugate of this matrix A. Okay. So next is rank of a matrix. We are already familiar with this. A positive integer R is said to be rank of matrix A. The number of non-zero rows in matrix A is the rank of that matrix, denoted by row. So row of A equals to R, means R is the positive integer, means it is the number of non-zero rows in the particular matrix. Okay, so there are two characterization or properties of rank of matrix. Rank of null matrix is 0 as it is containing only 0 as its elements. So rank of the null matrix is 0. If In is identity matrix of order n, then row of In, that is rank of identity matrix is n only. Because see, this is the identity matrix. Right? See, the number of non-zero rows is how much? 1, 2, 3. These are all non-zero rows. So rank should be 3. That's why not order. Rank of identity matrix is n. So for example, we can see here. Three, 1, 0, 7, 2, 1, 0, 0, 0. It is 3 cross 3 matrix. What is the rank of this? So rank of this matrix A is 2. Why? Because it is having only 2 non-zero rows. So the third row is completely 0. So we will not consider this. So rank of a matrix A is 2. So next one is determinant of matrix. Every square matrix A is associated with a number is called determinant, and it is denoted by determinant of A or mod of A type. So let us consider an example for determinant of a matrix. So take matrix A of order 3 cross 3. So 1, 2, 1, 3, 2, 2, 1, 1, 1. So how do you find the determinant of this matrix? Let us see. So first element, that is A11, 1. So A11 is alba. First row, first column we have to leave, and we have to calculate the remaining terms, that is 2, 2, 1, 1. So next is minus 2, that is A12, first row, second column we have to leave, and we have to calculate remaining terms 3, 2, 1, 1, 3, 2, 1, 1, and again plus. Alternatively we have to take the signs, plus, minus, like this. So next is A13 andre first row, third column we have to leave, plus 1, 3, 2, 1, 1, 3, 2, 1, 1 we have to take. How to calculate now? So 1 is 1 ಹಾಗೆ ಇಡಬೇಕು, 2 ones are 2, 1 2s are minus 2, like this. Minus 2 as it is, 3 ones are 3, and 2 ones are 2, plus 1, 3 ones are 3, 2 ones are 2. Okay, and next 2 minus 2 is 0, minus 2, 3 minus 2 is 1, plus 1, 3 minus 2 is again 1, 1 zeros are 0, minus 2 plus 1. The answer is minus 1 is the determinant of this matrix. So next topic is minors and cofactors. So let us take, if we consider the determinant of a matrix like this: A11, A12, A13, A21, A22, A23, A31, A32, A33. So let us take it as a matrix. So what is the minor of first element? Minor of 1 1, which is equals to M11. So minor of A11, nothing but first row first column we should leave. First row first column bitre ಇವಷ್ಟು ಎಲಿಮೆಂಟ್ಸ್ ಉಳಿತಾರೆ. ಸೊ A22, A23, A32, A33. So this is the minor of the first element. We have to calculate this in the particular matrix. So A12. So what is the minor of A12? ಅಂದರೆ ಫಸ್ಟ್ ರೋ ಸೆಕೆಂಡ್ ಕಾಲಮ್ ಬಿಟ್ಬಿಡ್ಬೇಕು A12 ಅಲ್ಲಿ. ಆಗಿಬಿಟ್ಟಾಗ A21, A23, A31 and A33. Okay, so minor of first row third column ಅಂದರೆ minor of A13. what it will be ಅಂದರೆ ಫಸ್ಟ್ ರೋ ಥರ್ಡ್ ಕಾಲಮ್ನ ಬಿಡಬೇಕು. ಸೊ ರಿಮೈನಿಂಗ್ ಎಲಿಮೆಂಟ್ಸ್ ಆರ್ A21, A22, A31, A32. We have to calculate this. A22, A31, A32. So in this way we have to calculate the minors. So cofactor ಅಂತಂದರೆ it is having a formula. What is that? Let us see. The cofactor of the element Aij is Cij equals to minus 1 to the power Ai plus j into Mij. So for example, take let us calculate the cofactor of A11. That is A11 ಅಂತಂದರೆ C11, cofactor of that element, which is equals to minus 1 to the power 1 means Ij 1 plus 1. Minor of Mij ಅಂತಂದರೆ M11 ಅದು ಮೈನರ್ ಏನಿದೆ 2, A22, A23, A32, A33. So in this way we will calculate the cofactors. Example, see, take 2 cross 2 element matrix. 2, 1, 3, 2. So in 2 cross 2 we will easily calculate that minors. So A11, what is the minor of A11? That is 2. Minors of elements will write. Minor of A12 is 1. So minor of that is 3. A21, minor of this A21 element is 1. Minor of this A22 element is 2. So cofactor of A11 element is minus 1 to the power 1 plus 1 into minor of that A11, that is 2. What do we get? It is minus 1 to the power 2 is plus 1, so 1 into 2 is 2. C12, minor of cofactor of A12, minus 1 to the power 1 plus 2 into minor of A12 is 3. So minus 1 to the power 3 is minus 1, minus 1 into 3 is minus 3. A21, minus 1 to the power 2 plus 1 into minor of A21 element is 1. So minus 1 we will get a to 2, minus 1 to the power 2 plus 2 into minor of a to 2 is 2. So cofactor of cofactor of element 2 is, it is 2 only. So these are the cofactors, these are the minors of this example matrix. So these are my topics in the first video. So in the next video we will discuss about adjoint of matrix and inverse of square matrix, and we'll discuss about row reducing echelon form, and we will find the rank of the matrix in the upcoming video. So until then, like, share and subscribe my channel. Thank you.